Part of the master plan is to have solar panels on the roof, but I also want a roof rack. I want to be able to put a snowboard up on top, or just not huge heavy things on top of the van, but I want to have that space available. Shortly after I got the van, I discovered that the medium height and the high top vans don't have any fixings on the roof for roof racks. You can't put a roof rack on them. The roof isn't load bearing. So I checked it out. I've got the design spec here on the screen, and yeah, that confirmed that this just wasn't an option. Because normally you would just have the various mounting points and the roof rails, and you just fit your kit along there. So that was a bit of a lack of planning on my behalf. I think I've got a solution though, but it's going to involve a little bit more work. So what I've got here is the CAD drawing of the van, which I managed to find on the good old internet. And from that, I can pull out some of the curves. For example, this is the side elevation, and you can see across the middle here we've got the roof of a mid-height van. And if I zoom in here, I've got a section around the middle of the van, and it shows the dotted line there is the mid-height roof, and the bit below is the rail, and that's actually where the roof rack would normally fit. So I could extend something up. Well, that's what I'm thinking. Up through a hole in that area of the roof there. So I'll need that curve of the roof. So I've also extracted out a view from the top of the roof. So this is looking down on the van from the top. It's quite a busy diagram, but what it's actually showing is all the points where the fixing holes are for roof racks in all the different variants of the roof. Then here what I've done is I've taken that view of the roof that we had before. I've just replicated across because I can use this to get a good view of how the roof's shaped. And finally, what I've got here, this is the side of the van, and I've just extracted that line out separately, also with some scaling information on it as well. Now I can import all those into a 3D program. And here we are in Fusion 360, and I've got those two profiles loaded in as sketches. So I've got the sketch there of the roof from the front or the back, whichever way you want to see it, and the side projection. That's just a line really, and the idea now is that what I'm going to do is I'm going to align those two. You can see there's that crossing point. There's a cross in both of them, so I'm going to replicate that shape and that sketch down there and align the two together just like that. And then what I want to do is basically move that shape along that path so that I get as close as I can to a reasonable approximation of the roof. Now this took quite a lot of time to get right. There was all sorts of issues with the sketch that I had to tidy up, but eventually it did work, and I ended up with this extrusion here. So I just extruded that sketch along that path, and ultimately I got something that looked pretty darn similar to the roof, and I was quite pleased with that. The other thing I wanted to take across was obviously the bars where the mounting points are for the roof racks. So normally this would be, just right under the roof, but in the mid height it's obviously some way down. I then took that plan telling me exactly where the roof points were, and I brought that in and aligned it to my same reference points. So now I've got all the roof rack mounting points mapped into my model, so I know exactly where the holes are. And in fact, these are the holes that keep the mid-height roof on. But I can map these now directly into my model and onto those rails that I added in. So here you can see I've done that. Now I did that through a sketch, but you can see I've now got these points mapped onto the rails. So they correspond directly to holes in the rails that the roof rack would normally fit onto. So what I want to do is build up from there. I'm going to use aluminium extrusion to do that. So the aluminium extrusion will need to bolt down directly onto these rails and effectively then extend the support up. Now I want to get that done very accurately. So what I've got here is the profile of the aluminium profile. That's the profile that is extruded. Now I got that from the manufacturer's website. I got all my profiles from KJ Aluminium, and very helpfully you can get the CAD files for the profiles off their website. Actually, this didn't work. I had to email them, but they got back to me really quickly. So I could load that into a sketch, into Fusion, and then I can extrude that out. And these were spot on. They were absolutely accurate, perfect. I was really pleased in the end with those. But there we go. So there's my aluminium extrusion. Now I did play with the height of these a little bit through the process. I think they're about 200 mil. But once I'd extruded one of those, I could then copy those and just literally center them in on those points that we'd mapped through from the CAD. So I know that there's holes in all of those points. I can just copy and paste my extrusions into all 10 of them. Now I didn't end up using all 10. I didn't use the one at the back. It seemed so close, but you can see there that they're all poking up now through the roof. So now I've got mounting points above my roof. So I had a little play around to see what sort of shapes I might put here. So you'll see later that I developed this a bit further. But I wanted, before I went any further, to build the rest of the roof rack, just so I knew what I was kind of building around. So using the same aluminium profile, the same sketch, I created the roof rails, which obviously will go along the side of the van, one on each side, and just exactly the same process, a sketch of that aluminium profile, which I extruded. And it's about 3 meters long, I think, as I remember. And then just mirror that over to the other side. Now we've got 2 roof rails. And then we need some roof bars going across. Now there are going to be 5 of these because I've got 4 solar panels and I want to connect them in between the roof rails. And again, it's the same profile all the way through. So I just moved them sort of roughly into position there. And that should give me enough room. Now I spent a while actually checking sort of clearances and stuff, which you don't see on this video. So I then wanted to have a slightly aerodynamic. I then wanted to have a slightly more aerodynamic shape over the aluminium profile there. So I made this little sketch here and extruded that down. It's fairly straightforward, but you can see the shape that I used there. It's that one there. Oops. So here's another view of how that's been built up. I've got my sketch here, which I extrude down, including the bits in the middle. Yeah, just like that. And that looks quite neat and aerodynamic to me. These are going to slot into the aluminium profile above. Obviously that won't work very well, so we'll just curve the edges a bit more. And then these center bits, I've curved those as well. Just put a little curve on just like that. Just makes it easier to slide the aluminium profile into it. And obviously I've put some curves on those edges as well. Now I want it to fit quite snugly up around the long roof bars, these here. So if I extrude that shape up again, and then effectively subtract away the aluminium profile from it, it will leave a lot of bits, but I can get rid of the bits that I don't want. So there you go. Right, so there's all those bits in there. So that's just one shape subtracted from the other shape. I'm just going to go in and delete all these rubbishy bits that I really don't need. That's way too much complexity. I just wanted that nice sort of sculpted curve on the outside. And then I'll just curve the edges as well a little bit more, like that. And these are lots of separate bits at the moment, but I'll merge them all together when I'm done. Now, in fact, this fit is very, very snug, so I need to give a bit more tolerance, a bit more clearance between the aluminium profile and the plastic, so that's just done there. Yeah, and merge it all together. Hide all the tooling pieces. And there we have it. That is, I call them rain guards. I don't really know what they are. They aren't really support. They're more there just to help make a good seal on the roof and to provide a little bit of aerodynamics to the roof bars. So just copy those across the whole roof. Now, some things I haven't shown there is the fact I'm actually cutting them in half. And I'm also sort of cutting away the roof shape from them, so I get exactly the right shape. I want to see what it would look like with the solar panels in place, so I've created some of those. Moved the rails about, made sure everything's going to fit perfectly, and it does just about. So now we've got a viable design for the roof rack. I wanted to see what it looks like, so I thought I'd do a render here. So this is just it'll apply a little bit more sort of graphics to the view. So I'm trying to get a view here that's sort of similar to looking up to the roof rack. So we normally look up at them rather than down at them, and something that'll give me a view. Yeah, roughly what's it going to look like. Now I'll shortcut the render here because it takes a little while, but I think that looks all right. So here's, if you like, the roof rack without any of the roof or the van. And in order to print these pieces, I need a flat side because it's 3D printing is additive. So I need a base. The easiest way to do that was just to cut them in half. They're not structural, so cut them in half. Now I've got a bottom, and I'll print the bottom bits upside down. So each of those has got exactly the right curve for where it is on the roof. The top bits, well, they're actually all identical. Well, they certainly are at this point in the design. So I'll need 10 of those, but I haven't labeled them. But the bottom bits I'll need. Now to print them, pretty much I select the item, and it creates me a little wireframe here, which I can import into Cura. So this is a slicer, and what this does is takes that 3D model and it slices it up into layers which the 3D printer can print. So printing ASA needs to be quite hot, 240 degrees, hot bed, had to build an exclosure around it. It does tend to warp. That is a bit of an issue with this printing, but it's been all right. So cooling was turned off. and I printed 2 to 3 pieces in each run. It would take probably around 14 hours for each one. So this was done over the period of a week. So this one there is 10 hours. So you can see it's showing you the sliced models, so we can go down through the slices down to the bottom, printing a brim to help keep things adhered to the print bed, prevent warping. You can see these are 2 top bits and 1 bottom bit. It's got the writing on. To print 3 at once, you had to get them quite close together, but that was all right. You can see there's an infill pattern, so it's not solid plastic. It's it's not a honeycomb, but it's a similar sort of idea, and that gives it quite a lot of strength, but it also gives it flex and reduces the amount of plastic you're using as well. This was printed with ASA print filament from Filamentive, which is, I think it's about 80 or 90% recycled, so it's a good use of otherwise unused plastic. And here's a little time lapse of it printing, and that's it for this video. If you have enjoyed it, then thank you very much for watching. The next video will be me actually putting it all together. I'll show you all these pieces that are made, but this video is very much just to kind of run you through the design, what I thought it was going to look like when it was on the computer, how I made these bits, how I got the design together, and I hope it's been useful or interesting, and I shall see you on the next video.